Hi, this is Eve Brantley, the Water Resources Specialist for the Alabama Cooperative Extension System. And today I'd like to talk with you all about the relationship between soil quality and water quality. First on our list is the question of how do we maximize both our soil resources and our water resources, thinking about making sure we get water where we need it most to our crops and as it is leaving our landscapes in the best quality possible as it reaches our surface waters. Throughout this brief presentation, I will hit on a couple of main points, including the importance of soil carbon, how we can look at the relationship between soils and plants to increase infiltration into our soils, the importance of decreasing soil erosion, and looking at the benefits of improved water runoff quality for both on-farm and off-farm benefits. Our friends at the USDA Natural Resources Conservation Service have a soil health initiative that outlines these steps pretty well. Minimizing disturbance, looking at plant diversity as a benefit, keeping a living root throughout the year in our soils, and importantly, keeping the soils covered and protecting them. So what's all the fuss about carbon? Carbon is a really important element. I'm sure you recall that it is what we need for energy. We have to have carbon to build our proteins, to grow. At the very base of our food web is photosynthesis that takes carbon from the atmosphere and transforms it into forms that then we can use, or plants, and also looking at carbon sequestration, how that carbon from the atmosphere is then stored in plant materials. Some common strategies to promote improved soil health include systems like cover crops and conservation tillage. I'm going to talk about cover crops as a part of that overall system as we discuss soil health. It's all about the roots. It is all about the roots. Roots in this whole system that is below ground, beneath our feet, that we can't really see. Research over the past several decades have just shown how important it is to take into account that below ground productivity, and a lot of it gets back to roots. Our roots produce exudates that are rich in nutrients and carbon, and that promotes a very healthy microbial and microorganism population in the soil. We're going to talk more about aggregate stability in a little bit. So these living roots are providing a benefit, but even after the roots die, they are still providing a benefit in that as they decompose, they contribute to below ground carbon sources. In fact, if you think about in the fall, when leaves fall and then you got to rake them up, or you can let them get into a big mulch pile and that decomposition begins, that turnover of root litter is happening all the time. There is that fine root turnover of roots dying and decomposing and feeding this whole below ground process. So sequestering carbon in the soil, or building up that soil carbon, is really important and beneficial. In fact, 3 times more carbon is stored in the soil than above ground. So as we look over time, this is a compilation of a lot of different studies looking at cover crops. You see that throughout all of these different studies, there is an annual increase of soil organic carbon, and that gradual increase is beneficial. And according to this paper, there won't be a saturation. There's the opportunity to continually improve soil organic carbon for over 150 years. So again, we know carbon is important. It's the base we need it for food and energy, to build proteins. But as we start thinking about, besides just feeding a healthy microorganism community, that soil organic matter benefits us by becoming a bank account, a savings account, if you will, for water. Every 1% increase in organic matter can mean as much as 25,000 gallons of soil water per acre. Another way to look at that is 1% of soil organic matter can hold up to an inch of water. So the more we incrementally keep that living root in the soil and promote healthy cover crops and healthy soil conditions, now we're able to store more water when it rains. And not just water in the top of the soil, but thinking about those roots also creating pores that, like little straws cutting down through the soil, that increase the depth that the water can flow. So now we've got happy organisms. So we've got this healthy microorganism community, and we've got larger organisms, these macro vertebrates, earthworms, and they are all creating macro pores too. So this below ground process of increased carbon, increased root depths, mean that we're allowing more water to soak into the soil where it can be available for longer periods of time. And when we enter into low precipitation times, like we have in 2016, every drop counts that we are able to get into our soil and store underground so that it can be plant available. Another benefit, so those are some pretty substantial on-farm benefits, is that the water, as it flows through soil is an amazing filter. So we can get improved water quality, which can be important for folks who are relying on groundwater quality, and as that water, for their wells, and as that water moves into local streams and lakes. And the concern then about water quality as it moves into local streams and lakes is having those living roots and living stems means that we can slow water down above ground with all the stems to allow the water more time to soak into the ground. And if there is a nutrient that is in the water and or attached to soil particles and it's traveling to a surface body like a pond or a lake or a stream, we can slow that down and minimize the amount of nutrients that can contribute to eutrophication, which is the rapid growth of plants and algae and water bodies that can really be detrimental to water health water quality. The pollutants that are commonly called out for concern, top of the list is phosphorus. In freshwater systems, this is generally the nutrient that limits plant growth. So just a little bit of phosphorus can add a lot of plant growth. You'll see here on the screen just 0.03 milligrams per liter, which is parts per million. That's all you need before you can start stimulating algae growth. The concern here, as I'm sure many of you are familiar with, is that the algae during the daytime photosynthesis, right? That's good. But at nighttime, when that algae begins to respire, where they're not taking in carbon dioxide, but they're taking in oxygen, they can rob oxygen from a water body. Another way algae, or this overabundance of algae, can rob oxygen is when it dies and falls to the bottom of a waterway and begins to decompose. So all those microbes begin decomposing it. Then those microbes are also using up oxygen. So we can get pretty low dissolved oxygen levels, which can lead to fish kills. Phosphorus is generally transported on sediment. It's not very mobile on its own. Nitrogen, on the other hand, is more mobile, and it can move in water as nitrate and then it not only can assist with increased plant growth, but nitrate becomes a human health concern in drinking water. So we want to minimize the amount of nitrate that has the opportunity to leach into groundwater, to run off into surface water, because we want to stay below that safe drinking water limit of 10 milligrams per liter. The human health concern is that excess levels of nitrate in water are directly connected with an inability of red blood cells to hold oxygen. So then it goes to a condition called blue baby syndrome. And those of you who deal in livestock know the concerns for high nitrite levels in feed, plus drinking water can lead to death. So we absolutely want to limit the amount of nitrate and nitrogen that make it to waterways. Cover crops also cover our soil. Remember, some of the key components were to keep the soil covered. The impact of a raindrop is like a little missile. It is a bomb on soils that are not covered. And that impact serves not only to hit the soil, but it dislodges soil particles. So now we've made soil particles available for transport to run off. And also these particles can clog up the surface or create a crust. So we're doing harm on farm in a couple of ways with this. If we don't have protected soil that's covered, we can begin to lose our topsoil through transport. As we get runoff, we're losing our infiltration rate because now we have the potential for those soil particles that have been thrown up into the air and detached to then, when they fall back down, create a cover or a crust that blocks the ability of water to soak into the ground during a storm event. We mentioned the importance of soil carbon as it relates to aggregation, or the strength of the soil holding together. You've probably seen a slaking test like this before, where soil from a conventional field is compared with soil from a field that has cover crops, where we keep that living root year round and as long as possible. And the soil that comes from the cover crop or the conservation tillage is able to hold its aggregate a lot longer than the soil that does not have those conservation measures. A lot of this is attributed to glomalin, which, if you've heard of glomalin, it was a surprise to me that it was only discovered in 1996. It's a fairly new discovery, looking at this glycoprotein from mycorrhizal fungi, which of course is a symbiotic relationship with plants, helping to improve their nutrient uptake. But this glomalin is like a super glue that assists with the soil aggregate stability. So it's, again, having these living roots that are producing all of these exudates and influencing so much of the below ground processes is incredibly important. And just to note there that there was a 4-year study where glomalin, again, looking at that soil carbon, and now we can see over a 4-year study, glomalin increased each year, which means improved aggregate stability and decreased potential for soil erosion as compared with other soils that are not in these systems. Getting back to losing soil, topsoil and the carbon that we build is so valuable to plants, and to protect that and not have it leave a farm and be transported away from those plants, that really important topsoil layer. So we absolutely want to protect that soil, not have it available for detachment and transport. There's been a lot of work done by our extension teams looking at that benefit for promoting cover crops and conservation systems on farm, again, increasing the infiltration and decreasing the potential for turbid waters or sediment-laden waters to leave a farm. Turbidity is a problem in that at just 50 NTU, and NTU is nephelometric turbidity units, at just 50 NTU, the sediment in waters, if it's suspended sediment, it can become abrasive to fish gills. So now we're starting to have impacts on in-stream critters. All right, and so it's not, you can see from this picture, 50 NTU is really not all that turbid. So it's fish and other organisms that live in streams have to get their oxygen from dissolved oxygen, or many of the organisms. So they have to be able to filter water through their gills. Turbidity also equals trouble for sight predators like bass. If you've got highly turbid waters, then bass aren't able to effectively hunt and get their next meal. And we should be concerned, of course, because our state freshwater fish is largemouth bass. Just thought I'd throw that in there in case you needed a trivia point. Turbidity is also trouble in that when the sediment that's suspended in the water column falls out and settles out, it then smothers the bed of streams and rivers, lakes, and it reduces the area that's available for some fish and other organisms to have breeding habitat, to just have good habitat to hide from predators. So it really just is smothering a system. So it's really important to keep sediment and soils in their place as we are looking at rebuilding soil health, but also those off-farm negative impacts can be really detrimental. And Alabama, I'm sure it will shock no one, is such a special place that we need to protect our streams and rivers. I'll touch on that in a minute. So we know that there are very little in this world is a quick fix. Looking at putting conservation systems into place is an investment. And so I think it's always important to note that starting off with looking at improving water, improving soil, it is an overtime commitment. In the first couple of years, there will be a transition period. This is a wonderful graph from our friends at NRCS, looking at what you can expect in the way of improvement over a period of time. So it's one of those things where it's like, you just got to trust me. We can see an improvement, but it will take an investment and a commitment to these systems. We talked about on-farm, being stewards not only of our landscapes, but of our neighbors as well, really gets back into some of these benefits. Some of the off-farm benefits for neighbors include improved water quality, improved air quality, and reduced greenhouse gas emissions. I mentioned how special Alabama is. We have 132,000 miles of streams and river. That's a lot. I mean, it's really astounding the amount of waters that we have in this state and how they are touched by so many different types of land uses, agriculture being just one. And the stewardship of our soils and our water on our farms means that we have improved water flowing into the streams and rivers that we rely on for recreation, for drinking water, and for irrigation for that matter. Just a quick note, because I can't get through a talk about water and streams without mentioning that Alabama is a global area of amazement for freshwater biodiversity. That is, we have more different types of critters like crayfish and fish and freshwater snails and freshwater mussels of just about anywhere else in the world. People come from all over the world to study what lives in our backyard. And thinking about replenishing the soils and increasing infiltration and having more water in that savings account, again, in 2016, we have experienced really dry conditions, and the forecast for 2017 is continued dry conditions. Being able to make every drop of rain we get go as far as possible is important now, and it's important when it starts raining, we get back to more typical average rain conditions. What I want to note here is that Alabama, on average, experiences a drought every 12 years. That drought may last 1 year or it could last 7 years. But we know that droughts are naturally reoccurring events. So planning now, thinking back to that graph, looking at we need to invest in improving how we manage our soil and water, and looking at how the plants that we put on farm can help with that, means that we can be prepared and make the precipitation that we get go further for when this drought ends and when we get our next drought. I mentioned air quality. The note from Natural Resource Conservation Service is there is less airborne dust with conservation tillage in these conservation systems. And because there is less need for trips across the field, it means reduced fuel costs for the farmer as well as a decrease in greenhouse gas emissions. All right, I want to stop here and say that's the close of just the introduction to the relationship between soils, water as we want it to infiltrate into our soils, improve water runoff, and the importance of plants and keeping roots, just really appreciating roots for what they can assist us with, and talk a little bit about the Clean Water Rule, or the waters of the U.S. So here's a quick update on this. Back in 2015, a report was released that had been requested by the United States Congress to have the United States Environmental Protection Agency and Army Corps of Engineers define and describe the rules associated with what is a stream, what is a wetland, and what is required if there is an impact, or what is part of an exemption. So this report was pulled together and released, and there were several findings that were very similar to what had been said before. A tributary has to have flowing water, have a stream bed, stream banks, ordinary high water mark. Waters that were next to rivers, lakes, and their tributaries had boundaries. There were boundaries set in this Clean Water Rule, and that isolated special areas, special wetland areas like prairie potholes, Carolina bays, Grady ponds would be included as protected. Ditches that were in the uplands and did not connect to a waterway were not part of this rule. They were not considered a regulated stream. Ditches that did connect directly to water bodies and could potentially degrade water or carry pollutants into a stream, a river, a bay, a lake, were included as something to be managed and not allow it to degrade water systems. Well, there were some concerns raised by several stakeholder groups that this Clean Water Rule expanded jurisdiction of areas that to this point had not been considered under federal rule. And there was a lot of interest in refining and defining this even more. And a term that you may hear frequently is, if you follow this, is significant nexus. How close does something have to be to a waters of the U.S. to be considered significantly close enough to impact it. Going to the rule, you'll see significant nexus is described as chemical, physical, and biological relationship that can influence or may influence a traditionally navigable interstate or territorial sea. So there isn't just one answer to this. It depends is the answer. So there were lawsuits filed, and lots of folks wanting to slow down the implementation of this rule until some clarification could be given. At this moment, the Clean Water Rule is in the 6th U.S. Circuit Court of Appeals. That happened in October of 2015. And they are looking at consolidating the different legislative, the different lawsuits into one case so that they can try everything at one time and I guess have a consistent answer or a consistent message to the litigants and those who are being sued. So pay attention. That will be unfolding in 2017, and I will keep up with it as best I can. But if you have any specific questions, please shoot me an email and let me know. And actually, if you have questions about anything, well, not anything, but water related or water resources, I will do my best to answer them. Email is the best way to get me. Feel free to shoot me a note at brantley@auburn.edu, and I will get back to you as soon as I can. And I hope that you all have enjoyed this presentation, and I look forward to future opportunities to talk with you.